Hello, everyone, and thank you for joining today's session. My name is Joe Schurman, and I am a partner at PricewaterhouseCoopers, otherwise known as PwC, focused on cloud engineering, application development, and artificial intelligence. Today, I'm going to be presenting a pretty unique topic that is outside the scope of my day job at PwC, and that is around artificial intelligence and UAPs, or unidentified aerial phenomenon. The title of this is focused around protecting aerospace while discovering anomalies, and I'll show you how myself and our team are working together with the US government and US military and within a group of distinguished scientists, researchers, as well as an extended team to produce some pretty interesting results and to research and analyze a lot of interesting content. So let's get started. So as a little bit of a background, some of you may have seen the New York Times article that was published back in 2017. The title of it was Glowing Auras and Black Money, the Pentagon's Mysterious UFO Program. And this is really the breakout announcement that the ATIP program, otherwise known as the Advanced Aerospace Threat Identification Program, was a funded program within the US government. And it was focused on the research of unidentified aerial phenomenon, as well as other phenomenon. And so at this time, there was a gentleman by the name of Lou Elizondo, who had left the ATIP program and joined an organization with a fellow colleague, Christopher Mellon, Chris being the former Deputy Assistant Secretary of Defense for Intelligence and a former staff director for the Senate Select Committee on Intelligence. He and Chris and a group of other individuals had come together to create To the Stars Academy, backed and also marketed by Tom DeLonge, a famous musician and artist. At that time, I had actually met and communicated and connected with Chris Mellon and was coming at it from a UAP data problem perspective based on my experience at NASA in a classified space, as well as my experience from an artificial intelligence data analytics research perspective. So in 2019, I joined the team as an advisor to the board at TTSA and really focused on the data issue and started building a solution atop of a capability I already had for analyzing images and videos and providing advanced data analysis and research based on the data that was actually reputable and authentic data to research further, leveraging modern artificial intelligence data analytics tools. Since 2019, the team has evolved and grown, and we are actually providing more advanced research and collaboration on this subject matter now that the U.S. government, U.S. military has, honestly taking this very seriously, and we are working together on the next phase of research and analysis for this actual subject matter. And I think you might find this pretty interesting as we go through this. So from the perspective of providing a platform for a unique problem like this, you can understand that there's so many diverse data sets that are involved. You have video, you have audio, you have documents in all kinds of shapes and form. You have information that's being sent out across a multitude of different agencies, some classified, some unclassified, documents and materials in various different formats, some readable, some not very readable. And then a trove of data and analytics information that needs to be correlated and analyzed for all kinds of different analytical insights and output based on certain variables. And then there's the combination of that data with factual data in terms of what happened in the actual date and time. What was the weather like? What was actually in the air, in the sky at that time this sighting was actually seen, or on land, et cetera. And so in the past, we've had specific point-to-point solutions that have provided individual capability, but what I really wanted to enable here was an end-to-end platform. And I also wanted to make this available via a secure cloud environment. And so I took a look at a multi-cloud approach to building this out and formed a team to go focus on this end-to-end strategy from data ingestion all the way through insights and analytics. And that's what we did. And what's great about having this as a platform, it's an all-encompassing capability. And as cloud-based and really more importantly, cloud-native capabilities have really matured over the past several years, we're now able to make use of those tools and services within the cloud versus only having to use on-premise or server-based and desktop-based technologies and tools. So from a perspective of the types of services and capabilities we wanted to include in this, it wasn't just image recognition or video recognition from a computer vision perspective. It was also deep learning and analysis, and being able to also look at this from a cognitive approach as well as an authentic approach, and providing a wealth, or I kind of call it a wall of AI to really attack this multitude of data sets. And in addition to that, protecting those data sets, and making sure that they are segregated when they need to be segregated, and that they are combined together for certain types of analyses. So that was really kind of the focus moving forward with this platform. And then atop of all of that, to provide a more modern visualization service, so that you can actually consume data and read data and view data in a more modernized way versus just a typical report or a dashboard. So these were kind of the thinkings in terms of the feature sets going into the design and the deployment of this platform. So starting off, we wanted to create a AI pipeline, or pipeline from ingestion all the way through analysis for this solution. But to do so, we had to stand up the platform, and we took a look at multiple cloud environments and landed on some specific key vendor environments, namely Amazon Web Services, just based on the maturity of their AI tools and capabilities, but also used combination of Microsoft Azure and GCP, or Google Cloud Platform, in certain specific areas where some of their tools and technologies were, also at parity or at a mature level to where we could use them. But from an end-to-end platform perspective, we provided a host of AI services ranging from creating the actual cloud native platform itself. We really didn't want to use third-party tools that were not native to a platform. So in Amazon or AWS, from a computer vision perspective, we had recognition. We had capabilities for creating a AI ML pipeline and series of Jupyter notebooks through SageMaker Studio. So those are just examples of tools and services, but the actual feature sets included computer vision, machine learning, natural language from a NLU, NLS, and engine perspective. And then also deep learning, fake analysis, as that continued to mature from a video and imaging perspective. And then automated intelligent automation, as well as a capability for data ingestion, storage, and authenticity checks and recursive response back on the data as it's being authenticized through the analysis and the visualization capabilities on the analytics side. And then what we additionally wanted to do is create a data science workbench, so that our data engineers and our data scientists can work together to not only look at it from a reflective analysis perspective, but also from a predictive analysis perspective. So based on the trends of, related to the specific data, we could start ironing out, or at least forecasting, dates, times, best likelihood of seeing a repetitive event or reoccurring event in more of a predictive analysis-based model. So again, part of the framework for the architecture around this. Now, from an end-to-end perspective at a high level, and I'll break this down, it all starts with the data. So we have troves of data dating back to the early 1900s through data sets like Project Blue Book, and I'll show an example of that, where there's thousands of incident reports. There's also troves of data online through various collection groups or organizations that have made some of those data sets public and available as well. And in addition to that, just a vast trove of data that we've obtained through our relationships as a team, across multiple locations, multiple subject matter project-based projects, et cetera, where it's come in again, across images, videos, documents, audio, interviews, spreadsheets, photographed typed documentation or handwritten documentation that all has to be accumulated into some sort of data ingestion service. So that's really the first thing that we do, is we pull all the media through, whether it's a document, image, audio file, data based file, et cetera, and hit it with this, wall of AI to really extract all the data from the data that we're ingesting so that it comes out in a common data format. So as an example, as I'll show you here in a minute, we would take a video or an image and then extract all the data from that video or image into a common data format, into a common data model, so that we can compare that data up against the other data that we have that might be coming in from other formats. So the first step is getting the information in, getting the documentation, imagery, videos, audio files in, and then providing an extraction of that data before we can even start analyzing. The second step is really analyzing the data as it exists in the data set that we extract from and against the existing data set that we already have. So as we continue to curate the data sets and grow those volumes, we want to continue to analyze the data separately and together all up. And in addition to that, we wanted to also provide correlative analysis based on factual data. So if you had an incident that was reported on a certain date, we want to know the weather, at that date and time that the incident was reported, what was location, what, just other variables that are factual-based variables, like, what flights were in the sky at that time, et cetera, so that we can continue to start building this trends-based analysis in terms of why these things are being seen or what is being seen potentially, and to try to really focus on ruling out some of the non-authentic data or mistaken data from that perspective. And then lastly, once we go through that authenticity process and do a bunch of trends-based analysis, et cetera, and really, start authenticizing or authenticating that data, we then put it into, more of a focused vault of data, if you will, or data set that is purely used for authentic research and analysis. And that's really kind of the end game. Of that data set can then be subscribed to, it can be reported off of, it can be shared amongst other data sets that we share as well. And we're not losing the data that we don't deem as authentic along the way. We still, provide analysis back on that, collect the data that has not passed an authenticity format or service. But we just want to make sure that we do keep those separate in terms of data sets that we do deem authentic and others that we don't. And then lastly, we want to create a curated machine learning library of those events and occurrences and learned experiences so that the next wave of data that comes through, we can continue to make the platform more intelligent. We'll give you an example of that, with video. So tracking a UAP, a computer vision model doesn't know what an unidentified aerial phenomenon or UFO looks like, right? So just like you would train it to understand and learn what a stop sign looks like, you have to do the same thing with an authentic piece of data that only our scientists and researchers can validate based on size, trajectory, flight pattern, exhaust type, et cetera. And so we continue to curate that library so that each net new video, net new image that comes through or drawing that comes through, we can provide a comparative match for that as well. So at a high level, that's pretty much the architecture overview. When you break it down, specifically, we take the source data, we extract the data, normalize it into a specific data schema, data model. That then moves into a staging data lake where we mash the data up against actual factual data, meaning flight, weather, satellite position, et cetera. And then we run our models based on the trends analysis to see other data that has been submitted before. Did that come out authentic? Did it not come out authentic? And then we progress the data further to more of an authentic data set for reporting and visualization overall. From a processing perspective on videos and images, again, we use tools and technologies like Amazon Recognition or Microsoft Video Indexer as a solution to really extract what we can see through a computer vision model. Now, again, we're given that base template or baseline tool set, but we have to create our custom labels and markers and dictionaries based on the research that we receive from our data science team, not just from the data that we have or the application out of the box. And that's what we have to continue to curate over time, and then continue to extract and match that data up against factual data. And we really gather a great deal of information off of all of these individual files and media types as they come through the system down to the lowest level, because authenticity is really the key in terms of processing through this service. So as a visual example, and I can show you this live, this isn't actually what's happening behind the scenes with our solution, but it's a good visual example of a tool called Amazon Recognition, where you can upload a video and actually see what the computer vision model outputs in terms of what it sees or determines it's seeing, playing just a video that you can upload directly to the screen. And I'll show you an example of that here in a minute when we go live in the demo. So from that perspective, here's an example of a video that we received from a trusted informant that's a U.S. government employee. And in this video, you really can just see the blue sky with white clouds. There's nothing behind the scenes here to the naked eye. but only playing it through a computer vision model like this, can you determine other elements that are in the video itself? And that's what we're able to determine, even based on the specific timestamps. And in this video alone, we could actually see that there were over 6 unidentified aerial phenomenon craft in this specific video hovering around this one location. And it's quite interesting to see that broken down. Now, again, we've used a combination of computer vision modeling and then advanced filtering capabilities through imagery software that we have access to. And that gives us the ability to provide a deeper look into the imagery itself. And so as a starting point, the computer vision model will detect something specific at a specific timestamp. That will allow us to zoom in specifically on that timestamp and then provide further research from an imagery perspective to uncover what might be seen that's naked to the human eye through this process. So again, just a quick example, and I can show you something live here in a few minutes. And then just some sample output from the computer vision model. In this specific timestamp, again, we're looking at just clear blue sky with clouds, but you notice that there was an airplane, aircraft, transportation vehicle with pretty high levels of confidence. 89% confidence there, 85% confidence in outdoors, 83% confidence in aircraft. So it gave us really good levels of confidence. And you see there 56% confidence in terms of spaceship on this video of a very clear sky. So this code, this output, if you will, this ability to, this metadata that we're pulling really helps us identify, but also validate, what we're seeing as well, which is pretty interesting. And if you see some of the videos and images we have access to, it's just mind blowing. Some of the data that we actually receive through here and post processing, that's even more awesome. In addition to that, like I mentioned before, from a data ingestion perspective, we receive a ton of documents like this that are either handwritten or typed so long ago and have been shelved and they're very difficult to read or understand. So we use text extraction services. This is an example of Amazon TextTrack. There are other tools and services out there. This is just part of a platform-based solution in the AWS environment that we use and we automate. So this is just a visual example, like the video example, of taking a document and being able to read thousands of documents in batch format or hundreds of documents in batch format, or just one by one, and be able to extract as much data as possible from these documents so that also ends up in this common data model and data set so that we can further research it and correlate it to other data sets that we have. So you're seeing an image, a video, a document now that's been extracted, and you now have data from that media that's been extracted into this analytical suite that we can start reporting off of trends and other types of data points. And then lastly, some of the other visualization stuff that we bring to the forefront has to do with mapping. And so we want to provide not only location-based mapping for specific incidents, like you'd see in the top right-hand corner of the screen, where we're zeroing in on specific activity, but we also want to make sure that we're showing a holistic view and providing layered approaches. So in this Google My Maps, example, this is just an example, we can provide an output where you can actually see the baseline number of Blue Book incidents as an example, and then layer on top of that military installations, which is publicly available data, in addition to nuclear plants and other types of location-based information that can be layered together. So once you start seeing these incidents that are reported, all in a map and all this extracted data from a dashboard perspective, analytics insights perspective, you can start seeing, just visualizing some of the trends together. So it makes it really easily available to start coming up with, specific scenarios, theories, et cetera. In certain situations, as an example, through the mapping interface, you can tell that there is a reported incident nearby a nuclear plant or nuclear site and a military installation. So, we start to look at that data and try to come up with scoring type mechanisms to where we're starting to authenticate, specific data so we can have a source of truth in a trove of that data to rely on for future data sets or to get as close to a source of truth as possible. And then in addition to all of this, we actually initiated a graph data analysis service so that we can start finding not only correlations across multiple data sets and multiple data types, but also anomalies in those data sets as well. And graph data services are excellent for doing that and have been used for the past several years holistically for fraud and other types of cyber research. And we are putting this to use heavily. And I'll show you an example of that as well. But being able to surface graph analysis based on subject matter, we can go across or traverse, emails, spreadsheets, databases, images, documents, videos, audio file transcriptions, etc., and find a correlation or where that subject matter has resolved itself across these multiple media formats and bring that together in a nice visual format so that we can further investigate based on specific subject matter, no matter what the data type is and what brings that together, using edges and vertices to really bring those data sets together, which is pretty impressive. And then lastly, where we're headed with this, and we're working on some prototyping now, we're creating more of an interactive tier. And this is more of what I call like the Iron Man approach. I've always wanted to see this really come to life, where we have all of the 2D or 1D visuals, if you will, from an analytics perspective, but to really immerse yourself in those. So what we're trying to experiment with, in the platform as well, and Amazon in the AWS platform has a service called Sumerian that provides a capability for AR and VR emulation, and it works across multiple devices, but it's kind of like an open source, if you will, on the AWS platform to create that AR VR experience. And so what I'd like to see, and this is in our roadmap and heading towards our next release, we'd like to create that immersive type experience where you can actually walk into a graph database visualization service or a map or XYZ analytical output, and really control the data with more of a immersive experience versus just a mouse pointer and a monitor. So we're heading towards that as we speak, and that I think will unlock some additional capabilities from a research perspective as well. And then last but not least, once we've gone through all of the research from ingestion all the way through reporting, and then when our researchers or individual subject matter experts and stakeholders actually get a chance to look at the output, that's where we start providing more of our authenticity checking. And once we deem something authentic, that is something that we're going to draw off of for the next wave of data that comes through. So we do provide a marking, if you will, of specific data types and data sets and incidents, so that those are marked as true source of truth, source truth based data services in a specialized vault of data upon completion of this entire process. And that again helps us with this continuous cycle. So I've talked a lot about this. I'm just going to pop out here and actually show you some examples of this stuff real time. So as I mentioned before, tons and tons of data. I'm just showing you the thousands of incident reports from the Blue Book project, which is publicly available as well. Now, it'd be really difficult for one human being especially in a short time frame, to be able to read through each one of these documents. And some of these documents are kind of comprehensive, some of them are short. But if you take this data set and you mash it up against a trove of other data sets, it's an overwhelming amount of documentation. And as you can probably see, being out in the news and seeing, on social media, so many videos that are being shared or images that are being shared on UFOs, UAPs, et cetera. There's millions and millions of incidents or shares, if you will, videos that have been shared over the past several years. So it's just hard to stay on top of all of that data. So what we try to do is ingest it into a data landing zone, if you will. And in this case, we use an Amazon S3 bucket for that. Once it lands in that landing zone, then we're able to kick off other types of activities and other features that we enable. So here's an example of a graph visualization based on specific subject matter that's traversing emails, spreadsheets, different outputs of images and videos, and just trying to find some correlation or anomaly across those different data sets. And you can see very easily how you can use graph visualization. This is an example using Tom Sawyer software sitting on top of our Amazon Neptune graph database. And you can really traverse the data sets pretty easily just based on specific subject matter, and also set up your own edges and vertices in the platform as well, so that you can start further aligning the data to your needs from analysis perspective. So just a quick example of graph visualization to find those correlations and anomalies. Like I mentioned before, again, we don't use this tool for every video that we pull in. This is just kind of the front end UI example of just the Amazon recognition capability. We also have used Microsoft Video Indexer for this as well. But you can see that as videos are recognized by Amazon Recognition, for example, the object detection and specific labels that they're trained to produce then show up visually on the screen in this demo. But in our example output that I showed you earlier, this is happening behind the scenes in an automated way, and we're able to load batches of videos through that process, so that we don't have to watch any of the videos up front, which is great. Only the ones that we really want to key in on, because there are so many videos that are sent to us, which is pretty. It's a pretty awesome service to use, and we can continue to build off that using that machine learning library as well, so that we can continue to curate that moving forward. As I mentioned earlier too, we use tools like Amazon Textract. Again, there's other third-party tools out there that you can use. We just wanted to have an end-to-end platform capability within the AWS stack specifically for this version. And as an example here, I've got a Blue Book document that is quite hard to read, and so we use text extraction. And this is just a visual example of how we leverage text extraction to analyze these individual documents, but are able to do that behind the scenes in an automated way to be able to handle thousands of documents at a time, or entire data sets that are provided to us, which is great. And then lastly, just providing a mapping capability that allows end users to filter or unfilter specific data just based on their needs. So if you wanted to pull off the incident reports, just look at nuclear plants and military locations and then overlay them with Blue Book incident reports, you can do so, or you can just specifically look at the incidents themselves. I think it's great to be able to really hone in on specific locations where incidents have been reported, nearby military sites, and if you overlay nuclear plants as well, you can really see how close in proximity some of these locations are, and it just provides a more immersive experience as well. So the last thing I wanted to cover here is the ability to automatically deploy this entire environment. So not only have we set up the ability to automate data ingestion, automate the data pipeline, the AI pipeline, the use of all these AI tools dependent on the type of data set that's coming inbound, we've actually automated the entire deployment and DevOps automation of this entire service. And that in and of itself has also been really helpful to us, especially when we have a specific interested party that wants to be able to research their own data and not specifically have access to our data, but wants the ability to use the platform. We have a set of infrastructure as code scripts that allow us to quickly deploy this entire capability within each individual cloud environment. So that's all I have to share related to the presentation today. Now I'd love to open this up for questions, and feel free to fire away. And thanks again.